The overall goal of this procedure is to obtain low-noise recordings of ionic and gating currents from voltage-gated ion channels expressed in Xenopus oocytes with high temporal resolution of fast-channel kinetics. This is accomplished by first injecting the recorded ionic channel mRNA into the frog oocytes. The second step is to create agar bridges by shaping the capillary tubing and then filling the tubing with a salt-containing agar solution. Next, the cut-open rig is prepped for experimentation by placing all the components, including the oocyte and agar bridges, into designated locations. The final step is to insert the microelectrode into the oocyte to allow for voltage clamp recordings. Ultimately, the recording protocol is used to show ionic currents from the ion channels located in the oocyte membrane.
The main advantage of the cut-open voltage clamp technique is that it allows for stable, low-noise recordings of a very large population of ion channels. It also allows for rapid resolution of channel kinetics.
Visual demonstration of this method is critical, as some steps, such as placement of the oocyte, the top chamber, and the agar bridges, are difficult to learn.
In this procedure, make at least 6 agar bridges by heating up one end of a borosilicate capillary tube in a medium flame for each of them. Make sure that the end of the capillary tubing is in the top portion of the blue flame. Once the capillary tube has heated up, use the forceps to make a 90-degree bend.